All right, confession. I've never actually beaten Pong on the hardest mode. Is it that I'm bad at video games? You'd probably be right. Should I be spending my time doing something better? You could say that. Will I beat the system? You better believe it. So, with all that in mind, I have constructed a game plan that is 100% foolproof. And we will beat the system. And we will not be the underdogs in the situation. This isn't like the Chiefs versus the Eagles. We're gonna actually win. Okay? So let's go. And before we start, I don't want to see any comments like, oh, Sajar, you're wasting your time, or, oh, just get better at it. This is important, right? We have to show that we can be better than AI. We can actually function in a world where AI is starting to take over. We have to beat Pong. So there's a common saying, if you can't beat them, join them. So we will beat the system at its own game. We are gonna integrate AI. We're gonna build something that is 10 times better than it. Smarter, faster, stronger, just better. This is the best way to show that you are intelligent, by winning in Pong. The first step in figuring this out is analyzing it. So let's look at what we have here. We have 2 paddles, a ball, a middle line, and then 2 scores. Don't look at the one on the left. That I was winning, I promise. It was gonna be the greatest comeback. It was gonna be insane. So like I explained earlier, we have 4 planes. The left, the right, the top, and the bottom. So the left and the right, we don't have to worry about that right now. The main issue is the top and the bottom. So when the ball bounces, it either goes to the top or the bottom, and once it hits there, sometimes the speed and the angle changes slightly. And it's really hard to predict. So we're gonna find a way to mimic the corner hitting and try to figure out the angle between which the ball moves to see if we can actually win. All right, for the first part, we need to be able to detect the screen so we can run image AI processing on it. So what we need to do is open up VS Code, and this might even take a while, just trying to figure out how to get. Or we could do that. I mean, guess coding's not that hard anyways. So let's do that now. Update the values of X, Y, Z. Nope. Nope. See, look, I did it. I can code, see? Fixed it. Professional over here, you know? All right, so the next step would be actually detecting the ball and trying to figure out how to move the paddles based on that. I don't know much about image detection, so it's time to Google. All right, so I actually found an article on object detection, so I'm gonna read through it and try to see what I can figure out. All right, I just found out about something called background subtraction, where it looks at the current image based on a static camera and then figures out based on what you have, runs a bunch of mathematical stuff, and then it figures out based on that what is potentially the background and what's the moving parts. For the Pong game is apply the subtraction and then see which portions are the paddle and the ball, and then based on that, we'll have something where we can just detect the main parts of the game. So we don't have to worry about anything else. So apparently, we don't just need this background subtractor, we need something else to also help figure out where the outlines of the stuff are. So we can kind of like draw an image as to what it looks like. So it's not like some big blob. And it's called a contour. And from what I'm seeing, it's a lot of math. I'm not gonna look into all of that, but from what I see, it's just like an simple drag and drop in the code and we're done. So I'm just gonna do that. I'm not gonna just, see, that's the good thing about machine learning. Sometimes you don't need to care too much about the math, just kind of let it be. All right, so I wanted to do this differently. So I'm gonna snap my finger and you're gonna see the background subtractor at work. So you see the original image right here, and then, nope. There we are. Okay, so this is what I did. All right, and for the contours, I'm gonna do kind of the same thing. So I'm gonna clap and then I'll have it change. So then Okay, I need to fix that. Okay, so I found out that there's something else I need to fix. I need to add something called canny edge detection, which is just another pre-processing technique to basically figure out where the edges on the screen are so that we can figure out where the paddles and ball are. This works pretty well for things that aren't very abstract figures, so in this case, we're pretty good. So let me just... Okay, cool. Maybe that's a bit too much detection. Let me fix that. All right, I think I fixed it, and it's pretty crazy. So, bang, there it is right there. Honestly, very happy with it. Look at that. I even took the liberty to make it only on the right half, just so that we can detect just the ball. Because I realized that we don't really want to detect the other paddle because that could throw off the model a little bit. All right, so I ended up hitting a little bit of a roadblock. So I need to actually detect the edges of the ball and of the paddle in order to move it to the right direction. But the issue is the scoreboard. It's blocking where the ball is, and I'm trying to figure out how to move it around and like what to do next. This is what I'm seeing. I have the program here, and I need to figure out some way to not detect the scoreboard. All right, so I did some cool machine learning stuff where I basically got every single contour, which is the area around each thing that detects, and I found the area, and I'm checking if the area is under a certain size to classify it as the ball. So I'm trying to figure out what would be the ball, and in doing that, I ended up with this. But the issue is let me just show you. It's pretty crazy. All right, so then let me turn on the game and let me show you. So see, I can detect the ball here. It shows up in the right half of the screen, but this is the issue right here. The game developers figured out that people will probably try to cheat it, and they made a fail-safe. So the middle line is classified as the ball because it's the exact same shape. This is actually a really big problem because there is no way to tell the system to look at this ball instead of that ball because they're both the ball. So when it crosses the middle line, it'll just see the ball has gone to the middle. So that'll make things 10 times harder. All right, so it's been a while. It's been about a week. I've been spending so much time on this. It's absolutely insane. I have messed around with this code for hours, just trying to figure out what portion do I need to fix to be able to get it to work. Yes, I tried ChatGPT, I tried DeepSeek, I tried Claude. None of them had the answer, but I just started moving around code willy-nilly, and I think I figured something out. So I changed this line right here. I'll go into a bit more if it does end up working, but I'm feeling very confident, so I hit record. I'm feeling pretty good about it. So, I'm a bit nervous. All right. I need to run the application. I'm forgetting how to do things today. CV2 is not defined. What do you mean CV2 is not defined? Okay, 1 second. Error. Okay, I fixed it. Let's go easy, just to see. It doesn't matter, but I'd rather go easy. Yes, yes, it works. Finally. This is taking so long. I've spent a lot of my time on this. But the only issue is that it's still detecting the scoreboard whenever it changes, and if it's like a 5 or something, it'll count the middle back portion of it as a square. So I don't know how to fix that, but I did do some more thinking, and I realized that we need to actually consider both the right and the left side so that if you want to do a prediction of where it's going, like I mentioned in the beginning, we can actually go based on where it bounces. So transition right now. Okay, fixed it. That was a pretty bad transition, but speaking of bad transitions, I'm going to transition to today's sponsor, Brilliant. Building AI for simple games like Pong may seem easy, but under the hood, it's a lot more complicated. You've got things like reinforcement learning, decision making, optimization, and that's just to name a few. Overall, learning all these things can feel very overwhelming if you don't have a structured plan. And that leads me to today's sponsor, Brilliant. Brilliant helps you get smarter every day with thousands of interactive lessons in math, science, programming, data analysis, and AI. Brilliant is a learning app that actually helps you learn by doing. Instead of just watching videos, you get to interact with concepts and solve problems step by step, a method that's been proven to be 6 times more effective than passive learning. Their approach starts with the basics and builds up your understanding naturally. So you're not just memorizing, you're actually getting it. And the best part, everything is created by experts from Stanford, MIT, Caltech, Microsoft, Google, and more, so you know that you're learning from the best. Also, Brilliant makes learning super convenient. You can learn anytime, anywhere, right from your phone. With fun interactive lessons, you can dive into a new topic or squeeze in a quick practice session whenever you have a few minutes. The How LLMs Work course breaks down large language models, the tech behind AI chatbots, so you can understand and even build one yourself. Brilliant makes learning engaging and effective, focusing on the most useful concepts while letting you learn by doing. To try everything Brilliant has to offer for a free full 30 days, visit brilliant.org/SajarHenry or scan the QR code on screen. Or you can click on the link in the description. You'll also get 20% off an annual premium subscription. And thank you to Brilliant for sponsoring this video. All right, so after a few hours of just trying to put everything together, I think I got something. All right, so I made a way to track the ball, finds the contours, and then does some math, basically narrowing it down to only finding the ball in the center. And then I did some basic way of calculating the position, and then it moves to that location. All right, so you can see it here. It's not working too well, but it's the best we have so far. Yeah, that was miserable. All right, one more shot, one more time lapse. Let's go. It's actually not bad, you know, but this isn't enough to beat it. All right, so that did end up working, but it was actually pretty bad. If you see here, you can see that it started detecting the scoreboard, which is what I was worried about earlier, and I'm not too sure how to fix it because the numbers have squares and we still need to get that top part of the screen because if they hit the ball there, we need to know where it's gonna go after that. So I'm gonna put some more time into it and figure it out, but let's see how it goes. All right, so I made changes to the code. So what I changed was this portion of the background subtractor. So I added the history, the var threshold, and the ability to detect shadows. So the history is just about how many images it can process at a time, and it uses that to help figure out which portion of the background it wants to keep. The threshold is basically how sensitive it is, so that'll help us in figuring out which portions it wants to keep versus which ones it wants to leave. And detect shadows just detect shadows. So I want to set that to false so that we don't get any repeat objects. And for the last portion we have here, I added Gaussian blur. This is basically reduced noise in the frame that we have. I want to be conscious of your time, so I'm not going to spend a ton of time rambling on what Gaussian blur is. I think it's fine. I wouldn't do that. What's that sound? Gaussian blur is basically AI's built-in motion blur. It looks something like this. You've probably seen stuff like this in video games before. It smooths out all the chaos and it basically shows exactly what the AI needs to focus on. It's kind of like when you're running and you're looking at something directly, so then everything else around you becomes a blur. Without it, the AI would see way too much noise, kind of like the security cameras in the 1900s. You just see little dots moving across the screen and you can never really figure out who's the person. And if we apply it to our use case, we get crystal clear object tracking. So we can get rid of all these little dots here and just focus on the ball moving across the screen. So yeah, totally not wasting your time with this explanation. It's cool, right? Right? I don't know what that was. Let's go back to it. All right, so this is everything with the background subtractor and the Gaussian blur. I'm chugging a little bit here. OBS is in the way. Come on. Okay, it's not doing bad. Just didn't move there. Hasn't scored yet. Okay, so I think what's happening here, first we're gonna try it on easy, but I think I'm capturing too many frames at once, so let me cut it down to like 24 frames, so it's like a bit more reasonable. I'll do hard one more time. Let's just see where we're at. First point goes to us. It's not looking good. It's not moving fast enough. Okay, that was another flop. All right, so I just reviewed some of the footage, and after looking at it, I realized that every time it bounces off a wall, especially when it's further away, it struggles in figuring out where it's gonna go. So what I'm gonna do now is try to figure out if I can calculate the velocity when it bounces off corners to try to detect where the paddle should go. It won't be perfect because it's not an exact number I can get, but I'll do my best to get as close as possible. So let's do some math. All right, so I actually think I fixed the program, and I think it's about to win. I just had to start recording because this is pretty crazy. Come on. Okay, one more, one more. Let's go! Finally! I did it. Let's go, Team Human! I had won, but it didn't feel genuine. It felt like I cheered on a friend from the sidelines as he won his own race. But one thing I did learn is that humans continue to develop and grow, and even when something may not work at first, the power of the indomitable human will is strong within all of us. And with this, I realized that maybe AI wasn't all that, and maybe humans could compete at a similar level. Let's go! Let's go! We beat it. Finally.